Hello students, let me help you with your assignment. Make sure you have your math notebook ready. If you have the worksheet, that's great, but many of you don't, so you need to do this on paper in your math notebook. In your notebook, write the title on the page. This is assignment 8.7.4, Practice Problems. And before you can do this assignment, you need to take some notes. There's something you need to know. You need to know the quotient rule. And I'll explain that really quickly. Quotient rule. If you have the same base divided, then you can subtract the exponents. Let me explain. Okay, if I ask you, what is 10 to the 7th divided by 10 to the 5th? Then you need to use the quotient rule. First, write out the numerator in expanded form. So that's 10 to the 7th. Remember, the exponent 7 represents repeated multiplication. So we're multiplying the number 10 7 times. And in the denominator, we have 10 to the 5th. Please write it out in expanded notation. Now, when you've written it out this way, you can see that this 10 divided by 10 cancels out because 10 divided by 10 is 1. This 10 divided by 10 cancels out. This 10 divided by 10 cancels out, and so on and so on. It may be helpful if I prove it to you this way. I'm going to rewrite this another way and you can prove it to yourself that this is true if it's been a while since you studied fractions. This is equal to 10 divided by 10 times 10 divided by 10 times 10 divided by 10. I can write it this way and it is equivalent. 10 divided by 10, 10 divided by 10, and then I've got these two more 10 remaining here, so that's times 10 times 10. So when you have a fraction that shows a lot of multiplication on the top and a lot of multiplication on the bottom, you could split it up like this and it is exactly the same. It's equivalent. So that's what I meant by 10 divided by 10 equals 1. That cancels out. So that's 1. This equals 1, and this equals 1. So that's 1 times 1 times 1 times 1 times 1 times 10 times 10. Please follow along on your paper. I want you to show this to yourself on your paper so that you believe it's true and it feels natural to you. Okay, so here we have 1 times 1 times 1 times 1 times 1 times 10 times 10. Well, 1 times anything doesn't change the value. So I'm left with 10 times 10, and that in exponential form is 10 to the power of 2. So go back to what I originally showed you up here. You can see that 5 of the 10 pairs in the numerator-denominator cancel out, and I'm just left with these two. In other words, 10 to the 7th divided by 10 to the 5th equals 10 to the 7 minus 5. That's how many canceled out, and that gives me 10 squared. Now that I proved it to you, I can write the quotient rule. If you have some base divided by some base, and let's say this exponent is m, that can be any number, and this exponent is n, that can be any number, but the same base, then the answer is going to be the same base to the power of m minus n. Let me say this one more way. If you are dividing the same base, you can subtract the exponents. Now you know the quotient rule. You should have this in your notes. This is very important. You need to use that for these problems. Oh, there's one more thing you need for these problems, but I showed it to you in the last assignment notes. In case you've forgotten, though, I think I better show one more time. I'm going to take the number 10 and write it as an exponent. In exponential form, 10 is 10 to the first power. If I multiply by 10, I get 100, and that is 10 to the second power. If I multiply by 10 again, I get 1,000, and that is 10 to the third power. Now, what if I divide by 10? This is important. Please show it in your notes. Divide 1,000 by 10, and I get 100. And the exponent decreases. If I divide 100 by 10, I get 10, and the value of the exponent decreases again. Well, now let's keep going so that you know negative exponents. Let's divide by 10 again. So take the number 10 now and divide that by 10. 10 divided by 10 equals 1. And the exponent is, what do you think? Well, this exponent was 3, this exponent is 2, this exponent is 1, and so we say now 10 to the 0th power equals 1. And this is an important rule you need to remember. Anything to the 0th power is going to equal 1. And I just proved it to you. I want you to show it on your paper and prove it to yourself. But I'm actually not done. I'm going to keep on dividing by 10. So take the number 1 and divide by 10. You get 1/10. And as a decimal, that's 0.1. The exponent is, what do you think it is? 3, 2, 1, 0, -1. That is 10 to the -1. I'll just do 2 more because I've already showed you this in yesterday's assignment. Divide by 10 again. So take 0.1, 1/10, and divide by 10. But wait, I want to refresh your skills for fractions. So I'm taking 1/10 as a fraction, and I'm going to divide that by 10. Can I please do that on a sticky note as a side note? Because I'm going to review fractions for you real quick. I'm taking the number 1/10, and I'm going to divide by 10 again. Do you remember keep, change, flip? The number 10 is the fraction 10 over 1. And if I divide a fraction by another fraction, I do keep, change, flip. 1/10 divided by 10 over 1 is equal to, keep this the same, change the sign to multiplication, and then flip this one, flip it to 1/10, and then multiply straight across. I hope you remember how to divide by fractions, and if you don't, here's a very fast refresher. So multiply straight across, and I get 1 over 10 times 10. 1 over 10 times 10. I'm going to write it that way on my paper, and now you see where I get that from. Wait, go back to that a second. I'm going to write this one more time. We started with 1/10, and I said divide by 10. Now in the result, you see that when I'm dividing by 10, it goes down here and it goes into the denominator. It multiplies with the denominator. See, right here. You need to know that and be very comfortable with that. So please practice keep, change, flip until you can get this result automatically. When you divide by a number, it goes into the denominator. It multiplies into the denominator. That's important to know for when I keep going. So I'm taking 1/10 and I'm going to divide by 10. So I get 1 divided by 10 times 10. And I just proved that on my sticky note. Watch that again if that was too fast for you, and reproduce it on your paper to prove it to yourself. Anyway, 1 divided by 10 times 10 equals 100th. And as a decimal, that is 0.01. Let's do it again one more time. Divide by 10 again. So I'm starting with 1 divided by 10 times 10, and I'm going to divide by 10 again. So like I said, if I divide by 10 again, then I get another 10 in the denominator because of keep, change, flip. That equals 1,000th. And as a decimal, it's 0.001. Oh, I forgot to write the exponent on top of my little graph here. Oh no. Back up. So that was 10 to the first power, 10 to the 0th power, 10 to the -1 power. What is the next exponent going to be? Well, look back at the beginning of my chart. The exponent was 10 to the third, and then I divided by 10, and I got 10 to the second, and then I divided by 10, and I got 10 to the first, and I divided by 10. Every time you divide by 10, the value of the exponent decreases by 1. So 10 to the -1 decreases by 1. When you divide by 10, you get 10 to the -2. And when you divide by 10 again, you get 10 to the -3. I want you to reproduce this chart on your own without watching the video. I mean, watch the video, do it with the video, stop the video, cover your paper, and try to do it on your own. You need to be very comfortable with this. You need to know, look at the side of my paper here, you need to know that 10 to the 4th equals 10,000. You need to know that 10 to the 3rd equals 1,000. You need to know that 10 squared equals 100, and 10 to the 1st equals 10, 10 to the 0th equals 0, 10 to the -1 equals 0.1, 10 to the -2 equals 0.0, there we go, 100th. 100th is 0.01. 10 to the -3 equals 0.001, which is 1,000th. And 10 to the -4 equals 0.0001, which is 1/10,000th. You need to know these and be very comfortable with them. And I showed you where they come from. Now we're ready to start the assignment after you do this on your own in your notes. Okay, let's do the assignment. I've got it opened up already on my computer. This is 8.7, Lesson 4, Practice Problems. So find that in the Google Classroom. Right here, Assignment 8.7, Lesson 4, it says Dividing Powers of 10, but it is Practice Problems. So look for that. There we go. I also like to call it 8.7.4 Practice Problems. Okay, first one says evaluate. I bet you don't know, like, what the heck evaluate? What does that even mean? It means find the answer or simplify this expression to find the answer. Let's evaluate. 10 to the 0th power equals, what does that equal? That equals 10 divided by 10, which is 1. Go ahead and enter that in your computer as a number. Ta-da! 1. And submit your answer. Go to the next problem. Okay, 10 to the 3rd divided by 10 to the 3rd. Can you evaluate that one? If I went so fast and you feel lost, go back and watch it again. And I can help you too. 10 to the 3rd power in expanded form is 10 times 10 times 10, divided by 10 to the 3rd power. Now you can see that everything cancels out. So 10 divided by 10 equals 1, 10 divided by 10 equals 1, 10 divided by 10 equals 1. even if I look at the original fraction here, I see that the same number on top and the bottom. So I'm dividing by the same number. Anything divided by itself equals 1. Please say that out loud right now. Anything divided by itself equals 1. And go to the next problem. Okay, let's try this one. We have 10 squared, which is 10 times 10, plus, not times, plus 10 to the first power, which is 10, plus 10 to the 0th power, which we know is 1. What does it equal? I should write this one out. 10 times 10 is 100. So that's 100 plus 10 plus 1. What does that equal? Do the math. 100 plus 10 plus 1. I'm going to cover my answer because I want you to do it yourself. The number 100 plus 10 plus 1. You can use a calculator if you want. And then go to the next problem. Ha-ha! I didn't show you. Because you can do it. You can do this. Okay, the next problem says, write the expression as a single power of 10. In other words, we want to simplify this. Instead of having 10 to the 3rd times 10 to the 4th divided by 10 to the 5th, you can simplify that. Should I write it out in expanded form? I will. 10 to the 3rd is 10 times 10 times 10. And that's being multiplied by 10 to the 4th, so 10 times 10 times 10 times 10, and divided by 10 to the 5th, 10 times 10 times 10 times 10 times 10. Now, you can see what cancels out. This 10 divided by 10 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 cancels out. And I'm left with 10 times 10, and that equals 100. However, it didn't ask for the number 100. It said, write it as a single power of 10. Well, okay, so forget about that 100. 10 times 10 equals 10 to the power of how many repeated multiplications? 2. 10 to the 2nd power. You need to enter your answer using the caret symbol. Because in computer language, the caret symbol means to the power of. You'll find that on your keyboard, number 6. Shift 6 is the caret symbol. Go to the next problem. Now, instead of writing this one out, I'm going to start using the rules that I taught you so that we don't have to keep writing them out. Remember the product rule. When you multiply the same base, you can add the exponents. Okay, take a look at this next problem here. 10 to the 4th times 10 to the 12th divided by 10 to the 7th. I'm going to write this a little differently. 10 to the 4th times 10 to the 12th divided by 10 to the 7th. I'll write it this way. Now, you can see in the numerator, I am multiplying 2 powers of 10. So use the product rule. When you multiply these 2 powers of 10, you can add the exponents. So just look at the numerator first. 10 to the 4th power times 10 to the 12th power equals 10 to the power of 4 plus 12. And that is 10 to the power of 16. Now, let me go back and put that denominator there. It didn't disappear. I just left it alone. Now I'm going to evaluate 10 to the 16 divided by 10 to the 7th. And I showed you the quotient rule in the notes, right? Remember that we can subtract the exponents when we divide the same base. So 10 to the 16th divided by 10 to the 7th equals 10 to the power of 16 minus 7, which is 16 minus 7 is 10 to the power of 9. Go ahead and type that into your computer, 10 to the 9th. You have to use the caret symbol and go to the next problem. Oh, this one is complicated, isn't it? Look what we have here. We have powers of 10 being divided and then raised up to the next power. You're going to have to use the quotient rule and the power to the power rule. I taught you the power to the power rule in the last assignment. Okay, first, let's start with what's inside the parentheses. 10 to the 5th power divided by 10 to the 3rd power equals 10 to the power of 5 minus 3. And all of that is raised to the 4th power. Do you see how I got this? I just started here and I did that division. I used the quotient rule. Now I'm going to simplify. 10 to the power of 5 minus 3 is 10 squared, and it's still being raised to the 4th power. Now we can use power to the power rule. I'm going to review that really quickly in case you forgot. So watch this and do it on your paper. 10 squared to the 4th power equals 10 times 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 10. If you write it out in expanded form, it helps you see what's going on. So we have 10 to the 2nd power 4 times. And if you count that up, we are multiplying 10 8 times. So it simplifies to 10 to the 8th power. 1, 2, 3, 4, 5, 6, 7, 8. Go ahead and put in your answer right now. 10 to the 8th power. And I'm going to cover it up to make sure you're listening. 10 to the 8th power. Use the caret symbol just like it tells you. Okay, how about this next one? Look at that. It's pretty complicated. I want you to write it on your paper first. 10 to the 4th times 10 to the 5th times 10 to the 6th. Divided by 10 to the 3rd times 10 to the 7th. Okay, in the numerator, you're going to use the product rule first, because when you multiply by the same base, you can add the exponents. In the denominator, you're also going to use the product rule first. Let me go ahead and do that out. So in the numerator here, 10 to the 4th times 10 to the 5th times 10 to the 6th is equal to 10 to the power of 4 plus 5 plus 6. Remember, when you multiply the same base, you add the exponents. In the denominator, 10 to the 3rd times 10 to the 7th is equal to 10 to the power of 3 plus 7. Okay, let's do that addition really quickly. So that's 4 plus 6 is 10 plus 5. That's 10 to the 15th in the numerator and 10 to the 10th in the denominator. Now we are ready to use the quotient rule. Remember, quotient means the answer after you divide. So we're finding the answer after division. That's quotient rule. 10 to the 15th divided by 10 to the 10 equals, and you're going to subtract the exponents when you divide. So that equals 10 to the power of 15 minus 10. Do the subtraction to get your answer. Do the subtraction to get your answer. Don't wait for me, you do it. I'm going to enter my answer because I can see what it is. You do yours and then go to the next problem. I didn't write it because you should be listening and thinking. Okay, problem E. On the paper, problem E. On your screen, it's problem PRABMTZT. I think you can do this one. Can't you? We're getting there. We're getting good at this. In the numerator, 10 to the 5th to the 2nd power, you're going to use power to the power rule. Remember, when you have some power to the next power, which is what you have in the numerator, you can multiply. Not you can, I'm sorry, you must. You must multiply the exponents because we have 10 to the 5th 2 times, so 2 times 5. And in the denominator, I want to write this out. I just love writing my math problems out. Okay, in the numerator, that equals 10 to the power of 5 times 2. And in the denominator, that equals 10 to the power of 2 times 3. The little dot is multiplication. That's not a decimal. So keep track of what you're doing. This simplifies to, in the numerator, right here, 10 to the power of 5 times 2 is 10. And in the denominator, 10 to the power of 2 times 3 is 6. We're not done yet. Now that we simplified the numerator and the denominator, we need to simplify the whole expression. We need to use the quotient rule. 10 to the power of 10 divided by 10 to the 6th. Remember, when you divide the same base, you subtract your exponents. So this is 10 to the power of, and I'm going to stop writing to make sure you can do it. Subtract the exponents to get the answer. You're going to have not a negative number, a positive number. And then enter it in your answer sheet right now. Woohoo, I got it correct. Simplify that. 10 to the power of what? So what is this exponent going to be here? That's strange. Did my next page not print? Just a second. That's terrible. I've had a printing disaster. No problem. I'll just do it on this blank page. The sun, it says the sun is roughly, so we're just going on notebook paper now. No problem, right? The sun is roughly 10 to the power of 2 times as wide as the earth. I think I'll draw a picture. Here's the sun. Here's the earth. It said the sun is roughly 2 times as wide as the earth. Okay, well, anytime I hear something like that, I want to draw my dimensions. So let's say the width of the earth is going to be E, and the width of the sun is 2E, because it's 2 times as wide. Oh, not 2 times as wide. No, 10 to the power of 2 times as wide, 100 times as wide. What am I thinking? 10 to the power of 2 times as wide as the earth. So take the E stands for the width of the earth. If I multiply that by 10 to the power of 2, that is how wide the sun is. So it's a lot wider. It's 100 times wider. You can't see that in my picture. Now, let's keep reading. The star KW Sagittari is roughly 5 to the 10 times as wide as the earth. Oh, goody, I get to draw a star. I don't know, something like that. And the width is 10 to the 5th. Gosh, did I say 10 5 times? I know. 10 to the 5th times as wide as Earth. Okay. Anytime you're solving math problems, like story problems, draw pictures to help you organize the information that you're given. Okay, question. Here's the question. About how many times as wide as the sun is KW Sagittarii? How many times as wide as the sun? So I'm going to take the width of the star and divide it by the width of the sun to see how many times as wide it is. So take the width of the star, 10 to the power of 5 times E, and divide that by the width of the sun. 10 squared times E. You know what? I want to label what I'm doing. This is star width divided by sun width. And we're going to get a ratio. Our answer is a ratio that says how many times larger. So if you divide the width of something divided by the width of something else, you find how much larger it is. You get a ratio. Now, let's divide these. Look at the 10 to the power ofs. Use the quotient rule to simplify them. 10 to the power of 5 divided by 10 to the power of 2 equals 10 to the power of 5 minus 2. And then E divided by E cancels out. Like I said, anything divided by itself cancels out. And I'm expecting that to cancel out because I'm finding how many times bigger it is, a ratio. So the width of the Earth doesn't matter. It's how many times bigger the star to the sun is. Anyway, my final answer is 10 to the power of, and then you do it and enter your answer. Use the quotient rule. It's just as easy as it looks. Well, let me see if I got it correct. I did. Ta-da! Uh-oh, now it says explain how you know. How do I know that the width of the star is 1,000? Okay, hold on. I'll help you with the writing. Here we go. Explaining your answer is kind of hard for students, so I'm going to show that part. I found how many times wider, not larger, sorry, wider the star is by dividing the width of the star by the width of the sun. There you go. That's it. I found how many times wider the star is by dividing the width of the star by the width of the sun. Okay, you can copy my answer, and I actually like that because then I know you're following along. It's also great if you put it into your own words. Okay, next problem. It says bananas cost, there we go. Let me get my paper ready. Bananas cost $1.50 per pound. Okay, so I'm going to put in my notes, you can do the next problem. Go ahead and draw something that you know means I stopped this problem and now I'm moving on to the next problem. Okay, so next problem. Bananas cost $1.50 per pound. Okay, I'm just going to say B equals $1.50 per pound. LB stands for pound, but I forget why that is. And guavas cost $3 per pound. So G equals $3 per pound. Okay. Kieran spends $12 on fruit for a breakfast for his family. Wait. Spends $12 on fruit for a breakfast his family is hosting. They have a grammatical error right here, not to. They should delete that. Anyway, total $12. Got it. You need to have this information written down. Let B be the number of pounds of bananas Kieran buys. Uh-oh. Then I can't use B here. Okay. I can't use G here either. Do you know why? They said, let B equal pounds of bananas, not price per pound. Okay, so I have to change my variables. Okay, no problem. And G is the pounds of guava. G equals pounds of guavas. Write an equation relating the two variables. No problem. I'm really good at this. So we're writing an equation saying how B and G are related. Well, they're related by the amount of money Kieran can spend. Kieran only has $12. So Kieran could buy all guavas and then not have any money left for bananas. Or Kieran could spend half of the money on bananas and half of the money on guavas. I'm going to make a little table right here, and I know you don't want that because you hated it when I did it a lot in Unit 3, but let's just do it again. Come on, guys, this is fun. On the left is going to be the number of guavas, and on the right is going to be the number of bananas. If Kieran buys 0 pounds of guava, then Kieran has $12 to spend on bananas. If bananas are $1.50 per pound, that would mean he could buy 6 pounds. Is that right? Yeah. No, 12. No. 24. Oh, no. I hate doing math in my head. I'm getting a calculator. $12 divided by $1.50. Oh, it's 9. 9. Here, let me just do it real quick. $12 divided by $1.50 is 8. Dang it, how can I possibly be a math teacher? I hate math in my head. So let me say that again. If Kieran buys 0 guavas, he can buy 8 pounds of bananas. If Kieran buys 1 pound of guava, then that's $3. So Kieran only has $9 to spend on bananas. So $9 divided by $1.50 is 6. 6 pounds of bananas. If Kieran buys 2 pounds of guavas, and guavas are $3 per pound, then Kieran has spent $6 on guavas and only has $6 left for bananas. Bananas cost $1.50 per pound, so $6 divided by $1.50 means only 4 pounds of bananas. Do you recognize a pattern? Every pound of guava means you get 2 pounds less of bananas. And that makes sense because guavas are $3 a pound and bananas are $1.50. If Kieran buys 3 pounds of guava, he can only get 2 pounds of bananas. And if Kieran gets 4 pounds of guava, that costs $12 and he can't get any bananas. So here's the relationship between guavas and bananas. But they didn't ask you to make this table. I just gave that to you for free. You're welcome. They asked you to write an equation. So here, let me do the equation now. We have a total of $12, and that's going to equal the pounds of guava times $3 per pound plus the pounds of bananas times $1.50 per pound. So how do you use this equation? Let me show this to you. In case you didn't understand this well in Unit 3, now's your chance to review. How do you use this equation? Let's say Kieran buys 2 pounds of guava. Then you put in 2 2 times 3 plus B times $1.50 equals 12. Now we can solve for B to get the pounds of bananas that Kieran can buy. Anyway, right here is your answer. Here is the equation. Please type it in right now to get full credit for this problem. 12 equals, I'm going to type it as 3G plus $1.50 B. And submit your answer. See you later. Go to the next problem. The next problem says, rearrange the equation so B is the independent variable. Complete the equation below. Okay, so this is also a good chance to review. I need to move to a sticky note because I'm out of paper. The equation I wrote is 12 equals 3G plus 1.5B, and I showed you where that came from. Now they're saying rearrange the equation so B is the independent variable. B is independent. If it is independent, then we're going to have G equals something, 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 and B is here inside the equation. And do you remember why that is? Because our input goes in and we get the output out. That input is independent variable. And the output is dependent variable. So in other words, the output depends on what the input was. And in this situation, that would mean the pounds of guavas that Kieran can buy depends on how many bananas he bought. So we're going to put bananas here in the expression. You would substitute in the pounds of bananas and then calculate the pounds of guava you can buy after that. So let's rearrange this equation to make G the dependent variable. I'll do that right down here. 12 equals 3G plus 1.5B. Okay, remember the rule that you have to do the same thing to both sides of the equation. And when you follow that rule, you can rearrange the equation the way you want. So I'm going to move 3G over here by subtracting 3G from both sides. Then 3G minus 3G cancels out, and I get negative 3G plus 12 equals 1.5B. Now I'm going to move this 12 to the other side of the equation by subtracting 12 from each side. I'm just rearranging the equation. Positive 12 minus 12 cancels out, and I get negative 3G equals 1.5B minus 12. I'm not done though, because I have negative 3G, and I just want G on the left side. So I have to divide by negative 3. And I have to divide everything by negative 3. So when I do that, negative 3 divided by negative 3 cancels out. 1.5 divided by negative 3 is negative 1/2. And the B stays there, so that's negative 1/2 B. Minus 12. Now 12 is also being divided by the negative 3. Let me explain. 1.5B is being divided by negative 3, and negative 12 is divided by negative 3. That's because this is subtraction, so I have to do the same thing to each one. If that's strange, please go back and review subtracting fractions. Anyway, Hopefully that's not confusing and I can keep going. If I have negative 12 divided by negative 3, I'm going to get positive 4. Okay, let me enter this in and see if I got it correct, because I didn't check it. And I don't know if there's a format I should be entering it in. But anyway, I get negative 1/2, and I'm going to put that in parentheses, like that. Negative 1/2 b plus 4. It says correct. So, wow, I guess the parentheses are good. Go ahead and try it yourself. See where it comes from. Make sure you can do this on your paper too. Don't just copy me. Now it says rearrange the equation. So g is the independent variable. And then it tells you, it gives you a good hint right here. B equals what? So if G is the input, then B equals what? I'm going to go back to my original equation. $12 equals 3 pounds times the number of pounds of, $3 times pounds of guava plus $1.50 times pounds of bananas. Now rearrange this to show B equals. Okay, let's do it. I'm going to subtract 1.5b from both sides so that, you know what, I'm going to do it even easier way. Hold on. I'm going to do it differently. Differently because it's much easier. I'm going to subtract the 3g from the left side and the right side. So I get 12 minus 3g equals 1.5b. And the b is on the right side of the equation, but that's okay. Let me show you that that doesn't matter as long as I isolate the b. Now I need to get rid of the 1.5, so I'm going to divide both sides by 1.5. And that's easy to see on the right that it cancels out. But on the left, what you have is 12 divided by 1.5 and negative 3g divided by 1.5. Because this is subtraction. So I have to divide both terms by 1.5. 12 divided by 1.5 is 9. No, it was 8. Hold on a second. I did it already. It was 8, wasn't it? 8, not 9. 8. Okay, 12 divided by 1.5 is 8. And then 3 divided by 1.5 is 2. And there's a g there. So that term's here. 1.5 divided by 1.5 canceled out, and I'm left with b. Now, I said it doesn't matter that b is on the right side, because I can rewrite this as b equals 8 minus 2g. Okay, let's see if I got it correct. B equals 8 minus 2g. Good. Ba-bum. Okay, next one. You need to draw a graph for this next problem. I've noticed that a lot of students just say my graph is on my paper, but I don't give you any credit if you say that. That's right. If you say my graph is on the paper, instead of listening to the instructions I gave you to describe it, you get 0 points. You either need to show me that graph or explain that graph. Don't you dare say my graph is on the paper, because I'm not even there to see your paper. You won't get any credit if you say my graph is on the paper. It says, Lynn's mom bikes at a constant speed of 12 miles per hour. Lynn walks at a constant speed, 1/3 of the speed her mom bikes. Sketch a graph of both of these relationships. Okay, you better really sketch this. Do not say my graph is on my paper. These instructions say you can do that, but you can't. You're not going to get any credit for that. But you know what you can do? You could tell me the slope of the line. Okay, let's do it. Lynn's mom bikes at a constant speed of 12 miles per hour. And look at your paper or sketch this in your notebook. On the x-axis are hours. So if there's 1 hour, Lynn's mom has biked 12 miles. Uh-oh, that's off the graph. So I'm going to just divide that by 2. And I'm going to say in half an hour, 0.5, then that would be 6 miles. There we go. And since this is a constant speed, Lynn walks at a constant speed. Time is okay, so think about just the mom on the bicycle. At time equals 0, she just started and hasn't traveled at all. She hasn't biked anywhere, right? And then after half an hour, she's gone 6 miles. So I'm pretty good at these linear relationships, and I only need to graph that much. Then this shows you that every half an hour, she goes 6 miles more. The slope of this line, the slope of mom's line is 6 divided by 0.5. 6 divided by 0.5 is 12, and that makes sense because it's 12 miles per 1 hour. Okay, now they say Lynn walks at a constant speed that is only 1/3. 1/3 of that. So if she biked 6 miles and Lynn walked only 1/3 of that distance, that would be 2 miles. Change colors. So she's walking, she's only gone 2 miles in the same amount of time. She also started from 0. So I can graph that right away there. Here are the 2 relationships. This was in the beginning of Unit 4, Unit 3. You will get no credit if you just tell me the graph is on the paper. So here's what you can do. Tell me the slope of the line. Okay. The slope of mom's line is 12 miles per hour, and the slope of Lynn's line is 1/3 of that. So that's 4 miles per hour. And then you can submit that to get full credit. So I know you paid attention and you saw me plot the points and you did it on your paper. And finish the assignment. That's it. Good job, guys. Bye-bye.